The Earth's climate hangs in a delicate balance, and human activities are pushing it to the brink. Scientists have identified 5 critical tipping points that, if crossed, could have catastrophic consequences for our planet. From the die-off of tropical coral reefs to the thawing of Arctic permafrost, these tipping points are interconnected and could trigger a cascade of irreversible changes. The stakes have never been higher, and urgent action is required to tackle the root causes of climate change and enhance resilience to its effects. We explore the 5 tipping points that scientists warn could destroy the Earth. The melting of the Greenland and West Antarctic ice sheets. As the Earth's temperature continues to rise, 2 colossal ice sheets stand on the brink of collapse, threatening to reshape our world as we know it. The Greenland and West Antarctic ice sheets, once thought to be eternal fixtures of our planet's landscape, are now melting at an alarming rate, and the consequences of their loss could be nothing short of catastrophic. The Greenland ice sheet, a vast expanse of ice covering an area 3 times the size of Texas, holds enough water to raise global sea levels by a staggering 24 feet. As the Arctic region warms at a rate twice as fast as the global average, the ice sheet's surface is rapidly melting, forming intricate networks of rivers and lakes that further accelerate the thawing process. Beneath the surface, warmer ocean currents are eating away at the ice sheet's edges, causing massive chunks of ice to break off and drift into the sea. Meanwhile, on the other side of the world, the West Antarctic ice sheet is facing a similar fate. This remote, frigid landscape, once considered one of the most stable regions on Earth, is now showing signs of rapid destabilization. The ice sheet is grounded below sea level, making it particularly vulnerable to warming ocean waters. As these waters seep beneath the ice, they are causing the ice sheet to melt from the bottom up, weakening its structure and making it more susceptible to collapse. The loss of these ice sheets would be nothing short of devastating. As they melt, they will release vast quantities of fresh water into the oceans, disrupting global ocean circulation patterns and altering regional climates. Coastal communities around the world will be inundated by rising sea levels, displacing millions of people and causing trillions of dollars in damage. Low-lying islands and coastal cities will be swallowed by the sea, and salt water will intrude into freshwater aquifers, contaminating drinking water supplies. The die-off of tropical coral reefs. In the vast expanse of the world's oceans, a silent catastrophe is unfolding beneath the waves. Tropical coral reefs, the vibrant and diverse ecosystems that have captured the imagination of humans for centuries, are facing an unprecedented crisis. These underwater wonderlands, once teeming with life and color, are now succumbing to a phenomenon known as coral bleaching, leading to a devastating die-off that threatens to reshape the delicate balance of marine life. The primary culprit behind this ecological tragedy is the relentless rise in ocean temperatures, fueled by the ever-increasing levels of greenhouse gases in Earth's atmosphere. As the waters warm, the symbiotic relationship between corals and the microscopic algae that inhabit their tissues becomes strained. The algae, known as zooxanthellae, provide the corals with essential nutrients and their vibrant colors. However, under the stress of elevated temperatures, the corals expel the algae, leaving behind ghostly white skeletons devoid of life. The consequences of this mass bleaching event are far-reaching and profound. Without the algae, the corals struggle to survive, their growth rate slow, and their ability to reproduce is severely compromised. As the corals weaken and die, the intricate web of life that depends on them begins to unravel. Fish populations decline as they lose their vital breeding and feeding grounds. The once thriving reef communities, home to countless species of marine life, become barren and lifeless, resembling underwater wastelands. The impact of coral reef die-off extends far beyond the boundaries of the ocean. Coastal communities that rely on the reefs for their livelihoods, such as fishing and tourism, face economic hardship as the foundation of their industries crumbles. The loss of coral reefs also diminishes the natural barriers that protect shorelines from the destructive force of storms and erosion, leaving coastal areas more vulnerable to the ravages of the sea. The abrupt thawing of Arctic permafrost. In the far reaches of the Arctic, a silent and insidious threat is emerging from the depths of the frozen ground. The permafrost, a layer of soil that has remained frozen for thousands of years, is beginning to thaw at an alarming rate. This abrupt change, driven by the relentless warming of the Earth's climate, is unleashing a cascade of consequences that could have profound implications for the entire planet. As the permafrost thaws, the once solid ground becomes unstable, transforming into a spongy, waterlogged landscape. The effects are visible and dramatic, with buildings and infrastructure sinking and collapsing as the ground beneath them loses its structural integrity. Roads buckle and twist, pipelines pipelines rupture, and entire communities are forced to grapple with the challenges of living on an increasingly uncertain foundation. But the impact of thawing permafrost extends far beyond the immediate physical changes to the landscape. Locked within the frozen soil are vast stores of organic matter, the remains of ancient plants and animals that have been preserved for millennia. As the permafrost thaws, this organic matter begins to decompose, releasing carbon dioxide and methane, two potent greenhouse gases, into the atmosphere. The scale of this carbon release is staggering. Scientists estimate that the Arctic permafrost contains twice as much carbon as is currently present in the Earth's atmosphere. As the permafrost continues to thaw, this carbon is gradually released, amplifying the warming effect of human-induced climate change. It creates a vicious cycle, where the warming climate accelerates permafrost thaw, which in turn releases more greenhouse gases, further exacerbating the warming trend. The consequences of this abrupt thawing are far-reaching and complex. The Arctic ecosystem, finely tuned to the harsh conditions of the far north, is being thrown into disarray. As the permafrost thaws, the habitat of countless species, from the iconic polar bear to the hardy Arctic fox, is being transformed, forcing these creatures to adapt or face extinction. The thawing also alters the delicate balance of the Arctic's hydrological cycle, affecting the flow of rivers, the formation of lakes, and the availability of freshwater resources. The slowing of the North Atlantic subpolar gyre. Deep beneath the surface of the North Atlantic Ocean, a powerful force is in flux. The North Atlantic subpolar gyre, a vast system of currents that plays a crucial role in regulating the Earth's climate, is slowing down. This gradual deceleration, driven by the complex interplay of atmospheric and oceanic factors, is sending ripples of change throughout the region and beyond. The North Atlantic subpolar gyre is a giant whirlpool of cold, dense water that circulates counterclockwise between Greenland and the coast of Europe. It is a key component of the global ocean conveyor belt, a network of currents that redistributes heat and nutrients around the planet. As the gyre churns, it draws warm, salty water from the tropics northward, where it cools, sinks, and begins its journey southward, forming the deep, cold currents that flow along the ocean floor. However, in recent decades, scientists have observed a troubling trend. The North Atlantic subpolar gyre is losing its vigor, its currents weakening, and its circulation becoming more sluggish. This slowdown is attributed to a combination of factors, including the melting of the Greenland ice sheet, the influx of fresh water from Arctic rivers, and the warming of the ocean surface. As the gyre slows, it has far-reaching consequences for the North Atlantic region and beyond. The weakening circulation alters the distribution of heat and nutrients in the ocean, affecting the delicate balance of marine ecosystems. Cold water species such as Atlantic cod and herring, which rely on the nutrient-rich waters brought by the gyre, are forced to adapt to changing conditions or face population declines. The slowdown also influences the patterns of ocean-atmosphere heat exchange, potentially altering regional weather patterns and climate. The implications of the slowing North Atlantic subpolar gyre extend beyond the realm of ocean currents and marine life. The gyre plays a critical role in the global climate system, helping to regulate the Earth's temperature by transporting heat from the equator to the poles. As the gyre weakens, it could disrupt this delicate balance, leading to changes in atmospheric circulation patterns, shifts in precipitation, and alterations in the frequency and intensity of extreme weather events. The interconnectedness of tipping points and the need for action. The Earth's climate system is a delicate balance of interconnected components and subsystems, each playing a pivotal role in maintaining the stability of our planet. However, as human activities continue to drive global warming, we are pushing these components closer to their tipping points, thresholds beyond which abrupt and irreversible changes can occur. The die-off of tropical coral reefs, the thawing of Arctic permafrost, and the slowing of the North Atlantic subpolar gyre are just a few examples of the tipping points that are already being crossed. What makes these tipping points so concerning is their interconnectedness. The crossing of one tipping point can trigger a cascade of events that lead to the crossing of others. These changes can then feed back into the system, amplifying the initial disturbance and pushing the Earth towards a new, potentially inhospitable state. The consequences of crossing these tipping points are far-reaching and devastating. The die-off of tropical coral reefs, for instance, not only destroys some of the most biodiverse ecosystems on the planet, but also threatens the livelihoods of millions of people who depend on them for food and income. The thawing of Arctic permafrost can release vast amounts of methane, a potent greenhouse gas, into the atmosphere, accelerating global warming and leading to sea level rise, more frequent and intense heat waves, and other extreme weather events. The slowing of the North Atlantic subpolar gyre, meanwhile, can disrupt the global ocean conveyor belt, altering weather patterns and affecting the distribution of heat and nutrients around the planet. These changes can have cascading effects on marine ecosystems, agriculture, and human health, with the potential to displace millions of people and trigger social and political instability. At the heart of this effort must be a recognition of the interconnectedness of the Earth's systems and the need for a holistic approach to climate action. We cannot address one tipping point in isolation, but must instead work to build resilience across the entire system, from the depths of the oceans to the heights of the atmosphere. This will require a fundamental shift in the way we think about our relationship with the natural world, moving away from a model of exploitation and towards one of stewardship and care. It will require us to recognize the value of biodiversity, the importance of healthy ecosystems, and the need to live within the limits of our planet's resources. The path ahead will not be easy, but the stakes could not be higher. The fate of our planet and the well-being of future generations depend on the actions we take today. There you have it. It's now time to hear from you. Imagine you're a time traveler from the future, visiting the present day to warn about the consequences of crossing these tipping points. What would be your most convincing argument to inspire action? Let us know in the comments below.